Please just confirm whether I'm audible or not.
बहुत अच्छा है
Hello,
यही होता
am I
है
audible? Please just confirm whether I'm audible or not. You can write in the chat box also. Okay, fine. So we'll start. Let us wait 2-3 minutes. Maybe another participant will join. So after 7:05, I'll start. Just after 3 minutes. So today actually we'll discuss about the week number 9, and which is about, let me just introduce, a differential analysis of the fluid flow. So we'll discuss about the mass conservation and stream function in the Cauchy equation. These are the today's topic, and I have question based on that only. So let us wait up to 7:05, then I'll start. So let us start. So the first question is, so I have theories also, but before going on theory, let us discuss a very basic question, which is related to from your previous week also. And the similar question I have already solved in the previous week. A flow has parallel curve streamlines and is steady. This flow has tangential, convective acceleration, local acceleration, normal convective as well as local acceleration, normal convective acceleration. So you have parallel curved streamline like that. Parallel curved streamline or equidistance. The distance between the streamline is same. So whether you have the tangential or convective acceleration or local acceleration, whatever, the option is given from A, B, C, D. So you just try to write your answer in the chat box, which option is correct, whether A, B, C, D. Please just try to write your answer in the chat box. So as we have discussed detail in the previous week, so here only a normal convective acceleration will be exist. If you have the such type of a streamline, a curved streamline, or which is equidistance. So the second question, this is related to, yes, this is related to your stream function. So remember please. So the explanation I think is given here. Here you can see when streamline are curved and equidistant, there will be a normal convective acceleration exist only because of the fluid particles are changing their velocities in both tangential and the normal direction as they flow the curve even and the evenly spaced streamline. So remember please. So I think in detail I have discussed about this question in the previous one. Okay. So here you can see just the curve streamline. The pressure at A will be the less will be the greater than the pressure at the B. That is the inner part. So here just try to think, and here the detail is given how the curve streamline happens. So for more detail you can prefer the previous videos also. So here actually we'll discuss about the second question in detail because I have already discussed. So question second is the flow of a liquid at constant rate in a conical tapered pipe is classified as steady uniform, steady non-uniform, unsteady uniform, and unsteady non-uniform. Which option is correct for question number 2? Please just try to write your answer in the chat box. Which option is correct? For question number 2, okay. So here you have the tapered pipe. Let us suppose like that. You have the pipe like that, and here water is flowing from here to here. So you have to understand here the definition of steady and uniform or non-uniform or unsteady. So definition of steady is at a particular point I am going to consider here as a flow parameter is velocity. So at a particular point your velocity or any flow parameter should not change with respect to time. So let us suppose at point P you are measuring velocity. So velocity with respect to time is not changing. That is constant. Constant with respect to time, it means with time means you have measured here velocity at 10 a.m. Suppose your velocity is 1 meter per second, and you have measured again at 11 a.m. your velocity is again 1 meter per second. So such type of flow is steady. But and this condition is possible in this tapered case, a tapered pipe, because whatever your velocity will be here, if the discharge is constant, if you are maintain discharge is constant, then what will happen? Here one condition should be there also. If discharge is constant, then whatever, if this is P1 at P2, the value at P1 and P2 will not be same, but with respect to time, if the value is here 1, the velocity may be the value here something else. Let us suppose X, capital X. So at a particular time, the velocity is capital X. After 1 hour, velocity also will be the capital X, because you are going to fix the discharge and this is your tapered the area of the flow. But this is the your definition of the steady flow. And uniform non-uniform means what? If your velocity with respect to space, if this is x direction, so in the x direction with respect to x, if your velocity is not changing with respect to time, that is with respect to space, then you can say the uniform flow. But here is not the case, because x is equal to, let us suppose, if this is x scale, here is 1 meter, from here 0, here is 2 meter. So at 1 meter velocity is 1, at 2 meter at a particular time your velocity is something else. So this is not uniform throughout the section. So the answer is steady non-uniform. So steady non-uniform flow. So option 2 will be correct for this question. So remember please. So this is very, very important. Okay. Now let us move on these are the some conceptual understanding about the pitot tube, static pitot tube. So these are things you can go through. If you have any doubt, you can ask, because these are the very, very important topics from your fluid mechanics. So now we'll start the differential analysis of the fluid mechanics. So in this, actually, the Navier-Stokes equation is very, very important for your fluid flow. Remember please, Navier-Stokes equation is very, very important for fluid flow and continuity equation. Very, very important. So lot of things I have put it here, but we'll go direct on the question answer, because here I'll not discuss the everything as okay. So these are things I have explained very well about the streamline and all. I'll discuss in the first question, but after that I will not discuss. In the first question I will discuss. Okay. Where is the question? And the potential function also I will discuss. Okay, here is the first question. So the stream function phi, the stream function phi of a flow field is given by the expression you have, psi is equal to x, y. The potential function relevant to this flow is what? So what will be the potential function? So here I'll give you idea about, so how you will remember the relation. So let me just discuss the relation first. Okay. So you know the continuity equation. So here we'll discuss about 2D flow only, because xy you have in your hand. So you know the continuity equation, del u by del x plus del v by del y is equal to 0. So when you will go for solve such type of problem numerically, you have to know these two things. u and v, you have the two variables. These are the variables u and v. If I want to convert these things in terms of this psi function, in terms of your stream function, then what we need to put at the place of u and at the place of v? What we need to put? So if here is delta x and here is delta y, if somehow if I write here delta y and here is delta x, and somehow this is delta x and delta y, somehow at the place of u if I write psi, here also write psi, and at the place of plus if I write minus, then del psi by del xy, del psi by del y del x will be the, if here is the minus sign, will be the 0, means that will be the equal. So if I write something like that, then we can easily replace this u and v in a single variable. Single variable means in the terms of phi. You can very easily write. So with this interpretation, with this understanding, what the initially the scientists have defined your, the researcher, I think Lagrangian, have defined your psi, that is u value, is what? Del psi by del y, and v is minus, because we need to put here minus for equate 0, minus del psi by del x. Remember please. So this is the basic definition of your uh, stream function in terms of velocity u and v. So if you will put here, let us suppose initially I have written del u by del x plus del v by del y is equal to 0. So if you will put u is equal to here del by del x and u is your del psi by del y plus del by del y and minus del psi by del x. Here you just think on, here I have put it u and y value. So you come up with del psi by del xy minus, because this is minus plus minus, del square psi by del y del x is equal to 0. Yes, if you will minus same thing, definitely will get the 0. So this is overall idea about the definition of your stream function in terms of your velocity component. Now you have to remember one thing, what is potential function. So potential function is very easy. U is equal to nothing but del u by del x. V is equal to nothing but del v del phi, remember, del phi by del y, and w is equal to del phi by del z. So remember please, you can apply these things in terms of for three-dimensional flow, but this is only restricted up to the 2D, remember please. And here one thing more, this concept you can use only for the irrotational type of flow. So remember one thing is very important. So curl should be 0. So these are all the things I have discussed here. You can go one by one very conceptually. You will feel very easy once you will go one by one my slides. So okay. So now let us discuss about the questions. So you have the stream function psi is equal to xy. So you have to calculate the potential function. Phi is equal to what? So how you will calculate? So you have the relation, this relation. U is equal to this and similarly u is equal to del psi by del y. V is equal to del phi by del y here, and V is equal to minus del psi by del x. So very easily you can do here. So let us first calculate your u value. You will calculate del psi by del y. So you will get x only, and V, when you will calculate, you will get minus y. So now I will put here u is equal to, now I know very well these two things, u and v. So now here you can put the x is equal to del psi by del x, and minus y is equal to del psi by del y. So now you can write this equation like that: x del phi here minus y del y is equal to del phi. And now integrate both sides. You can integrate both sides. After integration, what you will get? So the explanation is here, I have written very clearly. So initially you have this equation, you have this function, and now you can very easily calculate your u value and y values. After calculating, yes, so you know already the potential function relation I have already told you just few minutes back. Now you can differentiate. Yeah. So once you will differentiate, you will get what? Del psi is equal to x delta x. So when you will differentiate, you will get what? Here this xy del psi by del xy, and x is equal to what? X square by 2. So that's why here is written half x square, and you will get one constant, which is the constant of y, function of y. Here is del x. Similarly for this, similarly for, so where fy is your arbitrary function of y, because derivative with respect to x, y arbitrary function we have written with respect to y, because the derivative with respect to x removes any y only terms, because it is already, if you have any, that is, if you are different integrating with respect to x, then what will happen? The your the with respect to x, remove any y if any term is there in. So that's why we have written. And similarly you have differentiating this one. So if you will differentiate, then what you will get? So fy is equal to nothing but fy is equal to half, because you have these things, minus del psi by del y is equal to minus y. So you have del psi, and this is, you already know, this is differentiation. So if you will integrate these things, if you will integrate, then what you will get? You will get fy is equal to half so here is what? Fy is equal to nothing but y square by 2, already minus the similar things. So you can put very easily here in this equation, in the first equation, phi x comma y is equal to your half, that is x square by 2 is already there, and then you get the fy is your nothing but minus y square by 2. So you can just take a common and x square y square. So finally this is your potential function. So this is very easy question, but you have to remember one thing here, how you will convert from the x to y, the formulas from between the velocity function as well as your potential function and stream function. Then how you will integrate. If you get something like that, then how you will proceed for the final, how you will remove this one. So you know already del phi by del x, del phi by del y is nothing but function, the differentiation of y you can write like that. Once you will integrate these things, you will get what, fy, and this side you will get minus y square by 2 if you will integrate here. So the similar things. So remember please. So now let us move on the next question. Here is the next question. So what should be the jet component? What should be the jet component, that is W, for a steady flow field to satisfy the continuity equation having u is equal to x square y square plus z square and v is equal to xy, yz and z. So you have to calculate the W component. So what will be the W component? You have already u, v, and you need to calculate the W. So you just try to write your answer in the chat box, which option will be correct for question number 4. So you have 5 minutes. After 5 minutes, because this is a long question, so similar approach you will apply here for the W component. These are the very interesting topics which is generally asked in the GATE exam, basically from fluid kinematics, and the fluid dynamics also very important. But from these topics, you have to expect one question in your final NPTEL exam and also the GATE exam or other exam also, because these are the very conceptual topics of fluid mechanics, conceptual as well as easy and memorable. So that's why this topic is very important. We just try to think and try to solve this question. So now let us solve. So here we need to calculate the W component and you have the U and V. So how I will proceed? I have already solved for you. So basically you know already the continuity equation of three-dimensional continuity equation, which is del U by del X. A similar thing here is written, del V by del Y plus del W by del Z is equal to 0. This is your continuity equation, and you have your U component and the V component. So once you will integrate these things, that is, let us put here. So del by del X, and U is given X square plus Y square plus Z square plus V is given del V by del X, del V by del Y, and V value is XY plus YZ plus Z square plus del W by del Z. So once you will differentiate these things, you will get only 2x plus, here you will get x and here you will get z plus del W by del Z equal to 0. Then what you will do, del W by del Z is equal to nothing but 2x plus x, you 3x plus z, so minus 3x minus z. So this similar thing is written here, and now you can integrate very easily. So dw dw is equal to minus 3x minus z dx, and this will give you the function of x y z, and this is your, once you will integrate, then you will get what, minus 3xz, because you are, this is your x, remember please, and you are integrating with respect to z, this is not x. So minus 3x and z, and this is your z square by 2, because here is z and here you are differentiating with respect to z, so z square by 2 plus function of fxy. Why not here z? Because if you will integrate something with respect to z, then here z should not be there. X and y. Okay. So now you can write very easily. Your w is equal to nothing but minus 3xz plus minus z square by 2 plus fx comma y. So this will be your final answer. So I think option A is matching with this. So remember please. Now second question. The next question, the verify whether the function phi y cube minus 3x square y is valid potential function. Yes, no, yes, cannot say, not sufficient information. Verify whether the function phi y cube minus 3x square y is valid potential function. So you have to verify. Very important question. So please just try to write your answer in the chat box. So for this question you have 2-3 minutes. So please just try to write your answer. Okay, you are telling the option B is correct. Yes. Okay, let me just show you the answer. So, how you will check these things? So you have already in your hand these two formulas, because why we have, you have also the W is equal to del phi by del Z, but we are discussing about only these two because of the function is restricted with the U, that is X and Y. So only two dimensional. So we'll work with this equation. Now, so what will be the U? After differentiating, you will get the U value is, because you need to put here what? Phi value. What is phi? Phi is nothing but y cube minus 3x square y. So the similar thing here is put it. So you will get minus 6xy, and v here, this is 3y square minus 3x square. So you will get this. So now u comma v you have in your hand this. Okay, now already you know irrotational condition for 2D curl velocity. So if you will check the curl, then what you will get? You will get these things. W is equal to del u by del x and del u by del y. So now you can very easily here compute these things. So v is nothing but, v is your 3y square minus 3x. If you will put here v, so if you will integrate with respect to x, only you will get minus 3x minus 3 and x square. If x square, then you 2x, so minus 6x, and then after minus 6x, so you will get finally 0. So yes, this is a valid potential function. Since the velocity field derived from phi is irrotational, so phi is valid potential function. So remember one thing please, here I have already discussed, already I have shown you also here, the y velocity potential function is come, and why it is, and it is, you can write velocity potential function, you can apply with velocity potential function for a particular cases, which type, which are irrotational type of case, which is irrotational flow. You cannot write the velocity potential function for rotational type of flow, remember please. So if any question is asking about whether the flow is, this potential function is valid or not, so you have to check whether this potential function is follow the irrotationality or not. If it is not follow the irrotationality, because in fluid mechanics this concept is come for the irrotationality, so the irrotationality flow, because this is valid only for this only. As you know why this formula is come, because of del u by del x, you know the continuity equation already, del v by del y and del w by del z. So here you have the three unknown u, v, w. So you need to convert these three unknown in one single unknown. So for converting in a single unknown, so you have the this u, v, w in terms of a single unknown values. So you have the single unknown value in terms of phi. So v is equal to del phi by del y and w is equal to del phi by del z. So these things you can write only for the irrotational flow, means your curl should be the 0. So for this checking, we need to check these things only, whether the curl is 0 or not, or how you will write the curl in 3 dimension. Let me just show you the very basic things. Phi I j k del by del x, del by del y, del by del z, and here is u, v, w. So now you can write. In case of 2-dimensional, only you will restrict with this. You will, here I want to write. your I j del x by del x del y del y, and here is uv. So for curl of this, how we will write? Del v by del x minus del u by del y. This is y, and this is your w. The similar formula is here. Remember, please. Similar formula you can see here. This is your del u by del x minus del v by del y. So here you can see this is come from here. So remember, please, these all the things is very important. Now let us move on the next question. Very important question. A flow field is defined by a stream function is already here. A stream function is given y square minus x. Consider the set of streamlines. You have the set of streamlines phi 1 equal to 0 and phi 2 is equal to 2 meter square per second and phi 3 is equal to 4 meter square per second. What is the velocity of fluid particle at y is equal to 1 meter on the streamline y2 x comma y2 2 meter square per second? So remember, please. So here you have the three streamline. One streamline, this is the second streamline, and this is the third streamline. The second streamline is, first is 0 value, second one is your 2 meter square per second, and third one is your 4. So you have to calculate velocity of fluid particle at y is equal to 1 meter on the streamline. So streamline is y is equal to 1 meter means streamline. Okay. So y is equal to 1 meter here is given. So you need to put the value in the y, this equation. So that's why it is given on the streamline. So you have to focus in on this streamline. So question is asking about on this streamline. So velocity. So how you will proceed? Just think on that and try to solve within 5 minutes, please. Within 5 minutes, just try to solve this question. Very important question. So let me just show you answer. So as I have discussed already, so you need to calculate your velocity at the streamline 2. So you have the equation is psi is equal to x square y square minus x. So 2D incompressible flow, and you know already the relation phi is u is equal to del psi by del y and v is equal to minus del psi by del x. So what will be the value of del psi by del y is equal to nothing but, because if you will put here y square minus x, so after differentiation you will get 2y, and so u is equal to your 2y, and del psi by del x, so v you will get minus 1, because with respect to when we will differentiate with respect to x this function, you will get what, only minus 1. So this is minus 1, you will get the plus 1. Okay, on the stream function, on the streamline phi is equal to 2 at y is equal to 1, the point satisfied what, 1 square means whatever you are, because 2 is equal to psi is equal to y square minus x. So you need to calculate your value on psi is equal to 2. Already in the question is given. So at the place of psi you will put 2. At the place of your 1 is y you will put 1 square and then minus x. You need to calculate 1. So x is equal to what? X is equal to nothing but 1 minus 2, so minus 1. So if x is equal to minus 1, so x comma y is what? Minus 1 comma y. Y is already given 1. So your particle is at 1.1. So now you can calculate your u value and v value. Because in u value you have y. So 2y. So 2 into 1 you will get 2. And here you have v is equal to 1. Here is not any variable, only constant 1 value. So this is 1. So now the final expression you will get. Velocity is u square plus v square is nothing but your root 5, that is 2.24. So here you not need to calculate this value 1 comma 1, because you have only y. In the variable you have only y, and you know already the value of the y is this. But for similar type of question you need to calculate the minus x. If suppose that here is the x is here, and here if somehow it will come with the x, then you need to value x also. So by default x value is not here, so in this question not required, but you have to remember, you have to know how to calculate. Okay, so next question is option A is correct here, please. Now let us move on the next one. Okay, so next question is, here you need to check the continuity, whether this equation, these values is u, y, and this function of u with w is satisfy the continuity for incompressible flow or not. So divergence and both you need to calculate which option is correct. So now I'm taking 5-minute break, please. So if you want to also take, you can take the 5-minute break. So in between, if you don't want to take the break, you in between you just try to solve the question. Okay, so now let us discuss the solution of this question. So here we need to check the whether the function is satisfy the continuity or not. You know already the equation del u by del x plus del v by del y del w by del z is equal to 0. So what is del x? What is the first term? The first term is will come if you will put here 2x plus y minus x minus z is equal to 0. So here is 2, here the differentiation is 0, and here is your minus 1. So it is coming 1. So I think it is not. So I have solution also. It is coming 1. So it is not. Not satisfying the continuity. And the value of divergence is, so this is nothing but divergence means what? Divergence is, this is your divergence. So del is nothing but del by del x plus del by del y, and this is, and v is nothing but u is I j k, here also I j k. Once you will multiply these things dot product, then what the finally will come? Del u by del x del v by del y plus del w by del z. This the final equation will come. So divergence is coming what? 1. Sorry, so which option will be? Option B will be correct. This function is not representing your continuity, not satisfying the continuity equation for incompressible flow, and the divergence is coming is 1. Okay, so next question is, so here also you need to calculate the missing velocity component. You have the two component u and v. You have to calculate w. The similar question we have solved already just few minutes back. So please just try to solve which option will be correct. So you have 5 minutes for this question. Very, very important question. Easy also because we have just solved. So within 5 minutes, please just try to solve the question. Okay, so let us discuss. So we need to calculate here the missing velocity component, that is the W. You have already U and V. So similar things you will do here, whatever we have did earlier. So as you will calculate, you have, let me just write here the function x square plus y square and 2xy. So you have x square plus y square, and v you will have 2xy. So once you will differentiate this, you will get 2x, and once you will differentiate this, you will get 2x here also. 2x, 2x, and your w component, if you want to calculate, so you need to apply the continuity equation, three-dimensional continuity equation, because question is asking about your 3D values, that is w component. So similar thing you will put here. You know already. So this equation you know already. So del u by del x is nothing but 2x. Del v by del y is 2x. And similar you will get the 4x. So now you can very easily integrate. So after integration you will get dw integration is equal to your minus 4x dz. So finally you will get this one. Option B will be correct here. So remember please. Now, so you have the velocity stream function. You have the velocity stream function psi is equal to x square y. You need to calculate u and v, the velocity component. So please just try to calculate. You have, for this question you have only 3 minutes. So within 3 minutes please just try to calculate. Which option will be correct? So this is very easy question. So now let us just solve. So you know already the del psi by del y is your u and v is minus del psi by del x. So this will be your x square y square. So finally after integration you will get x square here and here you will get x square y and here you will get 2xy. So x square y u component, oh no sorry, if you are in differentiating with respect to y will not be here. So only x square, yes, this B option, and already here minus is there, so you will need to put minus here, so minus 2xy, so option B will be correct. So remember this. So here is solution is given, very clear. Now for the similar question, the continuity check using the stream function. So you have the stream function and you need to check the continuity, whether it is follow the continuity or not. The similar function, whether this function follow the continuity or not, whether satisfied only for x is equal to 0, always satisfied, and satisfied only for y is equal to 0. So again you have for this question 3 minutes. So please just try to solve and write your answer. Okay, so now let us I want to show you the answer. So here you need to check the continuity. So already we have calculated your u value. U value is nothing but x square and v is minus 2xy. And v is minus 2xy. So for the continuity, you need to just check with this formula. So del u is x square del x plus, so whether it is equal to 0 or not, so 2x and plus minus 2x. So it is 0. Yes, it is satisfying for always satisfied. So option C you can. So remember this. How you will solve? Remember. Okay, next question is, so streamline equation you have already. The for this psi is equal to the similar function you have here, x square and y square into y square, not comma. So you have to calculate here streamline equation. Streamline equation you need to calculate. So please just try to calculate what should be the streamline. You have again 3 minutes. These are the very important questions. These are linked questions, so you can correlate the things. Okay, so let us. So before moving to this question, I want to just discuss the previous one. Here is also very important thing. How? So you know one thing very from the last of few questions we are discussing these things. U is equal to del y and V is equal to del psi by del x. So in this continuity equation, you can put these things, because if you have one question, you need to check whether this stream function follow the continuity or not. So you no need to calculate these things, the x component and this is your u component and the v component. You can directly using this stream function, you can tell very easily whether the function is follow the continuity or not. How? You know these two things, the relation between your stream function and u and stream function and v. So now let us put here del u by del x plus del v by del y. So here I want to put del by del x, now del psi by del y plus del y, and at the place of v I am going to write minus del psi by del x. Then final equation is del psi by del y, this del square and del x del y minus this plus and minus will be the minus del square psi by del x square, del y del x is equal to 0. Now you can write very easily. From this equation you can also check whether this equation is satisfying or not. So let us differentiate first your phi with respect to x. It will come 2x. Remember one thing, your phi is equal to x square y. So when you will differentiate with respect to 1 time d psi by dx, it is come what? 2x y. When you will differentiate the same thing, whatever you have the value, you are differentiating the same thing with respect to y. Del psi by del x we have already, and then del y, then 2xy, and when you will differentiate these things you will get 2x. Similarly for this, the similar value will become, because you are differentiating with respect to x y, here also you are differentiating with respect to y and x. So if you will differentiate with respect to y these things, del psi by del y you will get 2x, and again del psi by del y and del x you will get how much? Here is not x square, because you have the function is x square y. So when you will differentiate with respect to y, then y will be equal to y is converted in 1 and x square will be remain here. And again when you will differentiate you will get 2x. So now you need to put here 2x minus 2x. So again you come up with the same things is equal to 0. So this is also the procedure for calculating your continuity check for a stream function. So remember please. Okay. So now what about this question? So you have to calculate the streamline equation using the your these values, the similar one, not y square. So how you will proceed? So for calculating the stream function, the equation first I want to show you the equation. So this is your equation. Streamline equation is nothing but from the concept your yeah, a streamline have psi value is constant everywhere. Or one thing you can say, a line having the same stream values, stream function value, a line having the same stream function value at every point, or it is nothing but it is showing the contour of the same stream function values. Remember please your stream line. So it is constant. So nothing but your x square y, this is psi value is equal to constant. So stream function is c by x square. You can write very easy. This is very easy question, but you have to know the things. And these all the theory thing I have already covered above. Actually not I have discussed, but sir I think already covered to all of you. So but here is very clearly I think I have defined. Let just I want to show you. I think a little bit above. I have put it the concepts here from the single symbol book. Actually, I am following the single symbol. So not here. Okay. Then yes, the stream function from here you can see very easily. So these are the equation. These are two equations, and these are the continuity equation. How you will satisfy? You will put here u value del y by del x, then you come up with this final equation whatever I was discussing, and then streamline. So you can see here for streamline del u by del x, so at the place of u you will put this thing del psi by del x, and again here, and finally you will get the total change in different, your phi is equal to 0, means your phi is equal to constant. This means what? Your phi is equal to constant. So similar thing we are using here. So for more conceptual you need to go with this content, or you can follow the single symbol book also. In the simplified version I have also written for you all of you. So please you go one by one. These are the very important things. So actually the theoretical part I have not discussed because this NPTEL TA program is specially designed for the question answer session. So I have not discussed the theoretical part. I have put it here theoretical part just for to all of you.
Okay, I found this on the web form designed for the answer. Check it out.
Okay. So let me just, okay, we have covered these things. Okay, 4 and 5 we have covered. Now let us move on the question number 6. Here, vorticity of the stream function you need to calculate. For phi is equal to x square y, you need to calculate the vorticity wz. 2x minus 2y plus 2y or t, which will be the correct? You have the 5 minutes for this because this is very tricky question. So remember please, you have to calculate the vorticity wz. So think on that and try to calculate it within 5 minutes please. Question number 6. So, so now let us discuss. So vorticity you need to calculate. So what will be the value of the vorticity? Like if somehow you forget the formulas, then you remember one thing. Your vorticity is nothing but is the rotationality. We are discussing about here is the two dimensional only. So I and j and del by del x, del by del y, and here u and v. And this is your nothing but wz, and you can say this is curl, the cross product. So this finally will come del v by del x minus del u by del y. So your wz is nothing but del v by del x del u by del y. So now you can very easily calculate. What will be the value of u? U is nothing but del psi by del y, and v is nothing but minus del psi by del x. So del psi by del y is nothing but your x square, and del psi by del x is nothing but your minus 2xy. So you can put here 2xy, or del v how you will with respect to x, so minus 2y, and here u with respect to y, so you will get 0, so minus 2y will be the final answer, your wz. So B option will be the correct. This is minus 2y. Remember. Next question. Okay. So irrotational flow check. Here you need to check the irrotationality of the given potential function. You have potential function x square minus y square. So you need to check the irrotationality, whether this is flow is irrotational or not. The function is follow the rotationality or not. We have already solved such type of questions. So for this question you have 5 minutes or 3 minutes. Within 3 minutes please just try to solve this question. Very important question. Okay, so let us discuss. So here you have to check the irrotationality. So how you will check irrotationality? Whether this potential function is follow or not. So for checking the irrotationality, you have the same equation and same concept here, what we have discussed. Here is the two-dimensional. So we'll write, you need to check the curve, whether it is follow or not. So what? Nothing but your I del v by del x minus del u by del y. You need to check this one, wz. So now let us hear what is u and what is v. So you know one thing, del phi by del x, del phi by del y is your u and v. So what will be the u? U will be your 2x, and what will be the v? It is 2y. Once you will put here, so this will give you 2x and this is 0. Here minus 2y and x square will be the 0 from this case. So now del by del x, and you have 2x minus del by del y, and you have minus 2y. So it is 2 and minus 2. You will get 0. So this is your irrotational flow. This function is showing the irrotational flow. One thing you can also do, you can write this equation in terms of phi itself. At the place of v, you need to write these things. Minus at the place of u, you need to write these things. Del phi by del x. So finally wz will come in terms of your potential function, del square phi by del xy minus del square phi by del y del x. So from here you can also you can do. So your double, the first differentiate with respect to x, so you will get 2x here, you can write very easily. This is, I want to write here del phi by del x, you will get 2x. Then again del phi by del x and del y, when you will do, then you will get what? 0, because the y term is not here. Similarly for this, first we need to integrate with respect to y. So what you will get? Minus 2y. When you will integrate with respect to x, again 0. So 0, 0, following the rotationality. You can do these things also. Okay. So why it is 0? Oh, sorry. Here I think I have made mistake. Your v is nothing but is 2y, and your u is 2x. Not 2 will come here. That's why here is not matching. So del by del x, and here you have the 2y, then 0, and then del y by del y, and you have the 2x. So with respect to y, it is again 0. So it will come 0. So here you can match. So these are the way. The next question is Laplace check, whether this is follow the Laplace or not. which option is correct? Del square phi is equal to 0, valid. Del square phi by 2, not valid. Del square phi by 2 is not valid. And del square phi is equal to 4. So which option will be correct? Check the Laplace. So you have again 2 minutes. Within 2 minutes, just think on that. So for the Laplace is nothing but whatever we have discussed, I have discussed here, just these things only. These things only. You need to think on that. Let me just show you. Here. Your Laplace operator is nothing but Laplace operator is this is. And what is this? Del by del x plus del square by this is I plus del square ij and k. And if you have the phi, then you need to multiply everywhere phi. So now you can think on that. So here we have not the z term, so this will be neglected already. So you have only x and y term. At the place of phi, you need to put del square by del x square, and phi is your x square y square plus del square by del y square, and you have x square minus y square. So finally, when we will double differentiate, you will get 2. And if you will double differentiate here, you will get minus 2, because x is del by del x, 2x, then again you have the another x, you have x square, that means you have another x. So del by del x is 2. Then here again is 2y, then again if you will do differentiate, then again you will get the minus 2. So this minus plus 2 and minus 2 definitely 0. So this is your valid one. A option is correct here. Now let us move on the next one. So Cauchy's equation force. The stress tensors you have sigma xx, sigma y and sigma z is equal to minus p. What is the force per unit volume? So here you need to calculate the force per unit volume. Force per unit volume. And you have the stress tensor is minus p. All normal values. Normal stress you have similar. Is equal to minus p. So you have to calculate the force per unit volume. So how you will think? This is a little bit advanced, so let me just show you the answer. So this is nothing but you have to just calculate your stress, your normal stress into del. So minus del, because you have the minus p. So this will be the, based on the option, we can do the more things, but based on the option, your final answer will be this one. This is not rho. This is rho, remember. This will be the rho, density one. But your del P will be the final answer. Then for today is the last question. So you have the velocity field and vorticity. You need to calculate velocity field and vorticity. Whether this represent the compressible or incompressible, and vorticity is 0 or something magnitude, it is 2. Which option is correct? A, B, C, D. Which one? So velocity field, how you will calculate? It is, if these equations satisfy your continuity equation, then you can say yes, it is. Or the continuity equation you have derived, this continuity equation is your representing the what? Incompressible fluid. Del V by del X. So if you will put here U is equal to minus, sorry, this is X and this is Y. So this will give you what? Minus Y, and this is give you X. So it will 0 and here also 0. So it is 0, yes. It is incompressible. Now you need to check the vorticity. So again, you have only the two components. So how you will check the vorticity? WZ you will check. So del V by del X minus del U by del Y. So del V by del X, it is 1, and again here minus del U by del X, it is minus 1. So it is 2. So what will be the final answer? This C here will be the final answer. Here you can see very easily. You have these two component, and you need to check this whether it is following the continuity equation or not. Yes, it is following. So that's why it is incompressible. Now you have to check whether it is the vorticity magnitude. So vorticity magnitude, as you can differentiate here, you will get this vorticity magnitude minus 1 and 0 plus 2. This is your final answer. So for today, that much. So thank you for attending the class. So, and the video is recorded already, and I'll upload as soon as possible on YouTube. So you who have not attended, you please go one by one. Or if you have any doubt, you can ask in the next class. I will upload also this PDF file in the Google Drive link. So thank you Ravi for your attending the class. So, thank you. Okay, thank you. Thank you. Bye. Now you can leave the class.